Guys, Mr. Bowman here. Today's learning objective is in green and we are learning to simplify algebraic fractions. And what we're going to do for today's video is we're just going to chop our screen up into 4 parts. And each part will be for each operation. So there will be one on addition, subtraction, multiplication, and division. So let's start off with adding. And the way I want us to think about these is I want us to think just like it's an ordinary fraction. How would we go about doing that? So let's say we had 1/2 plus 1/5. What we would do is we would do bottom times bottom, and then we would cross multiply 5 and 2, and we simplify that. That gets us to 10 or 7/10. So that's the crisscross smiley face method. When we're dealing with algebra, we can do the exact same thing as well. So let's say we've got 2a divided by 3, and we're going to add 4b divided by 5. We're just going to do the exact same process. So we're going to go bottom times bottom, which gets us to 15, and we're going to cross multiply. So 2a times 5 is 10a, and then we're going to cross multiply the other way. 4b times 3 is 12. So we're going to go plus 12b. And that there would be our answer. The only thing we do need to check is, do these parts have any common factors which we could simplify? In this case, they don't, but do keep an eye on any of those common factors that you could look to cancel out. So hopefully you can see what I mean here. The skills we use for regular fractions are going to be the exact same as the skills we use for algebra. So let's have a go at a subtraction question. So we are subtracting here, and let's link it to our regular number fractions. So let's say we've got 7/8 and I'm taking away 1/5. What would that come to? So same process, we're going to do bottom times bottom, which comes to 40, and then diagonal from the left first, that comes to 35, and then we've got the diagonal the other way, minus the 8. That's going to get us to 27/40. So that's the same process, fairly similar to addition, except the only thing is we've got that subtraction sign there. Let's have a go. How would that look for algebraic fractions? So let's go 2x cubed divided by y minus 4x divided by 7. So same process, we're going to go bottom times bottom, that's going to get us to 7y, and then we go diagonally from the left first, so diagonally down, so that's 14x cubed, and then we do the same in the other direction, minus 4xy. We then need to check, do each of these have common factors? In this case, no. A lot of you might be tempted to cancel out these y's, but we can't do that, because that 14x cubed doesn't have a y part of that, so that doesn't have the common factor as well. So again, hopefully you can make the connection. The same skill for the numbers is the same skill for the algebraic fractions. So let's move on to multiplication. So we're multiplying here. So we're multiplying. Let's look at an ordinary fraction. We've got 2/9 times 7/10. We're going to go top times top is how we would do that. So that's 14. Bottom times bottom, that gets us to 90. We then do have to look, can we simplify that in any way? And I can see these both have a 2 in common. So I'm going to go divide by 2, and that's going to get me to 7/45. So similar process is going to be for algebraic fractions as well. So let's come up with a really messy one. Let's do 2x squared y divided by 3z. We're going to times that by z cubed divided by x squared y. So it's fairly messy, but same process. We're going to go top times top, and we've learned how to multiply algebraic expressions before, so it's going to be 2x squared y z cubed. We're then going to do the bottom times bottom, that's going to be 3x squared y times z. And what we're left here, this is just a division question to simplify. So we've done a bit of that before. So first step is you deal with the numbers. So in this case, 2 over 3, that's the most simplest form we're going to get. So we'll leave that as it is, 2 over 3. We're then going to look at the x's. Both the top team and the bottom team have the same amount of x's, so they just simply cancel each other out. We're then going to move on to the y's. The top team and the bottom team again just have the same amount of y's, so they cancel each other out. And then we're going to finish up with the z's. The top team and the bottom team, you've got to compare them. Top team has more z's. They've got 2 extra z's, so that's going to become z squared. And the final operation, we're going to shift on to dividing. Again, exact same process. Let's think, how does that work for our normal numbers? So let's divide 4 over 7 by 1/2. We always did a switch. So we're going to switch the 1/2 into 2 over 1. So that's going to become 4 over 7 times 2 over 1. We then do top times top, which is 8. Bottom times bottom, which is 7. We're going to adopt the exact same switch for our division questions. So we'll do a slightly easier one this time. So let's have a look at 7a squared b divided by 2c. And that's going to be divided by a over bc. So just going to carry on my working. First step, we need to switch that second part around. It's going to be 7a squared b divided by 2c times bc over a. We then do top times top. So it's going to be 7a squared b squared c divided by 2ac. Once we've done this, we're just going to look, what can we simplify? We're going to start off with the numbers. 7 over 2, that's not going to change. We then look at the letters. The top team has 1 extra A, so we're going to put an A there. The bottom team has the only B's, so they stay there. And the C's are going to cancel each other out because the top team and the bottom team have the same amount of C's. So hopefully you found this video useful. I just want to emphasize, for each question, we looked at how the rules worked for regular numbers, and then we did an example of how those same rules, same processes apply for algebraic expressions instead. Thank you so much for watching, guys. I really appreciate it. Keep working hard and make sure you finish all the questions for today's work.